Okay. Example again, and del y over del x, it equals to 3x squared, okay, and with okay, y equals to -1 when x equals to +1. This is our initial condition. Okay. Solution: integral del y equals to integral 3x squared del x, okay, and the y plus c1, it's equal to x cubed plus c2, okay, and the general solution will be y equals to x cubed plus c2 minus c1. Also it can be written x cubed plus c. This is the general solution, okay, and that means, okay, let me sketch it on the Cartesian coordinate system. Okay, if okay del y over del x equals to 3x squared, okay, your y, that means f of x functions, okay, can be equal to x cubed plus c, okay, as you see, x cubed plus c. What's the x cubed plus c? It can be like that. This is x cubed plus c, okay, okay. Every blue curve part is x cubed plus c, integration constant. But in the question, initial condition has just been given, okay? And what was that? We know that, okay, +1, -1, that was the initial condition, okay? So that -1 equals to 1 to the cube plus c, okay, and the -2 equals to c, okay, the integration constant value is -2, so y equals to x cubed minus 2, okay, that's the particular solution, okay, and let me sketch it, okay, and the blue curve, this is -2, -1, 0, +2, +2, okay, this is the x cubed minus 2, our particular solution curve. Okay, and listen me carefully. In your book, okay, now we have to continue with the velocity, okay, and the acceleration. and the x denote position, and the x equals to x of t, it means with respect to time, okay, and the velocity average it equals to del x over del t, derivation to the part of time, okay, and it's equal to x of t plus h, t is time, and the minus x of t over h, okay, and the velocity v of t, it equals to del x over del t, okay, it's equal to x prime of t, right, and the speed s of t, it equals to, okay, absolute velocity del x over del t, and the acceleration a of t, it equals to velocity prime t del v over del t, and it's also can be written del square x over del t square. Example: finding a projectile's height from its acceleration initial velocity and initial position. Okay. And the y of 0 equals to 3 meters, okay, and the del y over del t at the time 0 with 0 is equal to 160 meter over second, okay. And only follow the question graphics, okay, and after that I'll explain it, okay. Okay, and this is ground level, and let me write the question again. A heavy projectile is fired from a platform three meters above the ground okay, with an initial velocity at 160 meters over second, find the projectile's height y, okay, above the ground as x function of time t if t equals 0, when the projectile three seconds later solution. Differential equation del square y over del t square, it's equal to minus 9.8 meters over second square gravitational acceleration, which is okay, and with the initial conditions, okay, and the velocity 0, it's equals to 160 meters over second, and the y0, and it was the 3 meters above the ground, so that's the y0 equal to 3 meters, okay, at the t equals 0, we don't forget it, and we know that del y over del t equals to v, and the del square y del t square, it equals to del over del t del y del t, okay, and we know that del y over del t, it's the v, okay, and the del over del t v, and it's equal to del v over del t, right? And we know that del v over del t equals to minus 9.8 because of the del square y over del t square was that. So after that we can write the del v equals to minus 9.8 times del t, and the integrate both sides of the equation, and you will obtain the vt, it equals to minus 9.8 8t plus integration constant, which is the general solution. Okay, and after that we know that v0 is equal to 160, it's equal to minus 9.8 times 0 plus c, and that means c equals to 160. Okay, and the vt equals to minus 9.8 t plus 160. That's the particular solution. We have just evaluated it by the initial value condition. Okay, and after that, del y over del t equals to minus 9.8 t plus 160. Okay, and integrate both sides. Integral del y, it equals to integral minus 9.8 t plus 160 del t. Okay, and the y of t, it equals to, okay, minus 4.9 t squared plus 160 t plus c. Okay, that's again general solution. Okay, and after that we know that y0 is 3, so it's equal to c, and we know that now c is 3, c equals to 3. I'm sorry, this is the particular solution. Okay, and what can we say about the particular solution is that, okay, y of t equals to minus 4.9 t squared plus 160 t plus 3. Okay, this is the particular solution. And now the question says us at t equals 3 seconds, okay, what's the position of the projectile? Okay, and the y of 3 equals to, okay, minus 4.9 times 9 because 3 square, and the plus 160 times 3 plus 3, and the y of 3 equals to 438.9 meters above the ground level. Okay, and the speed equals to absolute velocity. Okay, you can find lots of examples about the 2.11 subtopic, which is about this problems, okay, and of course acceleration problems and the velocity problems. You can find lots of problems, okay, and now I have just finished the second chapter of your book, and let me continue with the third chapter of your book. Okay, okay. Chapter number 3, transcendental functions. Okay, and firstly 3.1 which is the inverse functions. F of x equals to x cube, okay, and when you sketch it on the coordinate system, it's like that, okay, and this function is 1 to 1, and that means when you sketch horizontal line, okay, and if your horizontal lines meets at only one point, okay, on the blue curve, you can say this function is 1 to 1, okay, and another mathematical definition will be different, okay. Or we can call it 1 to 1, okay. A function f is 1 to 1 if f of x1 is not equal to f of x2, okay, and the x1 does not equal to x2, okay, and from this part f of x1 equal to f of x2, so that x1 will be equal to x2 if this function is 1 to 1, and y equals to x cubed, so x equals to y to the power of 1 over 3, so we can call f inverse of f, that means f to the minus 1, okay, inverse of f is equal to y to the 1 over 3, okay, and let me give you definition, formal definition, I'm sorry, of the 1 to 1 function, and also inverse functions. If f is 1 to 1, then it has an inverse function f to the minus 1, and the f of y equals to x, and the y equals to inverse of x if and only if x equals to f of y. Let me give you properties of inverse functions. A. It comes from the definition. If and only if x equals to f of y. B. That's important. The domain of inverse f is the range of f function, and the C, the range of inverse function is the domain of f function. The inverse of f of x function equals to x for all x in the domain of x, domain of f, and the D, f of inverse f of x, it equals to x, but that time for all x in the domain of inverse f function, and the f property inverse f to the inverse of inverse f function, it equals to f of x function, and the last property and the graph, that's important property of inverse f is the reflection of the graph of f in the line x equals to y. Okay, let me give you example. If g of x equals to square root of 2x plus 1, firstly we must evaluate if this function 1-to-1 or not, okay? And if g of x1 equals to g of x2, okay, and so that we can write the square root of 2x1 plus 1 equals to square root of 2x2 plus 1, okay, and after that 2x1 plus 1 equals to 2x2 plus 1. When you take the square of each equation, okay, and cancel this part, and you will obtain the x1 equals to x2, so that we can say g of x is 1-to-1, or another saying 1-to-1, okay, so it's invertible, and To invert it, x equals to g of y, it equals to square root of 2y plus 1, okay, and the x square equals to 2y plus 1, and the y equals to, okay, x square minus 1 over 2, okay, and this is the inverse function, and we can say the inverse g function equals to x square minus 1 over 2, okay, for all x is larger than or equal to 0, okay, and when you sketch the g of x function, okay, and the g of x function will be like that. Okay, and this is y equals to x, okay, and this will be the inverse this is inverse g of x, and the blue one is g of x function. It's reflect on the y equals to x line, okay. This is the x y, okay.